2, what about if we're giving something like this? We're still equating polynomials, but look, they're a bit horribler. They're a quartic. They're raised to the power of 4. They're of degree 4. So we could do it same old way. Okay, so we could go, all right, first have to expand. We'd first go x, we'd expand this bit out. So we'd go x squared. First outers, take 2x plus x, take 4, take 2, take 2, outside of ax squared plus bx plus c. Then we'd go, all right, that equals x squared outside of ax squared plus bx plus c. Take 2x outside of ax squared plus bx plus c. Take 2 outside of ax squared plus bx plus c. Then you expand all that through. Looks delightful, doesn't it? It doesn't, looks awful. So, what are we going to do? Instead of doing all of that, what I want you to do is notice some patterns. Excuse me. So, let's have a look at this. We want to know what A is. Now, we also have a whole lot of coefficients. We've got a coefficient in front of the x to the 4 term. We've got a coefficient in front of the x to the 3 term. We've got a coefficient in front of the x term, x squared term, coefficient in front of the x term, and just a constant over here. Alright, so we've got all these different terms. We want to equate terms. Now, notice that if you multiply x by x, you get x squared. If you multiply x squared by ax squared, you get ax to the 4. Now, is there any other way that you can get a term raised to the power of 4 on this side? On this side of the equation? Well, on the left-hand side. You think about it. So x squared by x squared, of course that's x to the 4. But now x squared, if you multiply that through, for all the others, it's not going to be x to the 4, is it? There's no x to the 4 possibilities here because we've got x times x squared times x. No x out here times x squared times x. The only way you can get an x to the 4 term is by multiplying x squared by ax squared. Alright? So that means we know that the term which is raised to the power of 4 on the left-hand side of the equation is actually ax to the 4. It's this times that, which gives you x squared, times ax squared. Alright? So instead of doing all of this stuff here, we can just go, alright, ax to the 4, that must be my term, which is raised to the 4th power, therefore a equals 1, because the coefficient in front of x to the 4 is 1, and a is the coefficient in front of the x to the 4 on the left-hand side, so a equals 1. Can you notice anything similar for the constant? What is going to form the constant? Well, if you multiply x squared by anything, it's not going to be a constant anymore. If you multiply x by anything, it's not going to be a constant anymore. So it must be when you multiply 2, or negative 2, it should be. Is that a take? Yeah, that is a take. I've just got lines going everywhere. So if you multiply negative 2 by c, that's the only way you get a constant term. Okay? So you can't get it anywhere else. So how do we do that just from, if we didn't have this now? That's just to help us. If we didn't have that, and we had just the equation up there, how are we going to look at that? Well, we go, well, the only way we get a constant out of this polynomial and this quadratic part is when you multiply the lasts together. We know that first out is in this last. The last term is the only constant term you'll get. So if you multiply those last together, you get negative 2. And then, if you multiply negative 2, that's going to be the last term of your quadratic that you form, because you're going to form x squared plus x take 2x. So you're going to form take x squared take x take 2. The last term of that is going to be negative 2. Everything else is going to be a variable, so it's not going to be constant. So negative 2 by this last term, which is c, which is the constant, is the only constant value. So therefore negative 2c must equal our constant over here, which if we erase our thing, is actually -2. So C must equal 1. I hope that sort of makes sense. We might run through this one again sometime, but just see if you can get your head around it. Try it with a couple of the examples. All right, thanks guys.